A very good day to the examiners and my fellow friends. I'm Vachalashni Kupusamy, the team leader for Group 39 of Integrated Design Project 2022. This is our supervisor, Dr. Sharifa Noor Faiza Sabki. This is me, myself, from Microelectronic Engineering, and my team members are Anis Nabiha Binti Safi from Electronic Engineering, Haris Mukri bin Muhammad Hajizi from Electronic Engineering, and finally Noorzad Alia binti Ahmad Sahari from Electronical Engineering. Our project is entitled as RBUS, which stands for RFID Based Attendance System. Manual attendance is biggest drawback because it is hard to monitor a large scale class in universities, and nowadays in COVID-19 pandemic situation it is advisable to avoid physical contact among people and the surrounding. These are the two main reasons why we Group 39 has invented a project which is RFID based attendance system using Arduino and auto sanitization system. An auto sanitization system has been incorporated in the project to reduce the risk of virus spread and to create a virus-free classroom environment in universities. We have provided a secure, portable and ready-to-use RFID-based attendance system that provides practical and efficient solution for large-scale attendance monitoring. This system acts as an easy tracking system which helps to keep track on students anytime because we have integrated our project to Excel to store data where this RBUS system will provide a better attendance recording compared to the manual attendance recording. Our four main problem statements in our project, which are time consumption, large crowd of students is hard to monitor, high technology attendance system is complicated to maintain and costs a lot, and manual attendance causes a lot of physical touch and exposure to the COVID-19 virus is high. We came up with three objectives to solve the problems that have been stated in the problem statement part, which are to provide an efficient attendance system using RFID, to test the functionality of RFID module tag with Arduino Uno R3, which only authorize the authorized UID, and to reduce the risk of virus by incorporating auto sanitization with the RBUS system.
Hello everyone. So this is chapter 2, methodology. So for introduction, this chapter defines how the objectives are achieved by using flowcharts, uh, basic block and architecture block, all the research, design, instrument, tools, data source and data collection and presentation that we use in this project will be provided. Okay, so we have a specific approach taken to execute this project. This approach emphasizes step-by-step development and by finishing each step before we proceed to the next step until the final stage of prototyping. So we begin with the title of the project. So we discuss with each other. We find out what was the problem, and a title was selected based on the problem statement, which is RBAS with auto sanitation. RBAS stands for RFID based attendance system. Then we proceed to research. We did a research on the theory and concept from eligible sources. Uh, It is crucial to have an acute understanding for the project to follow all the basic theories. Okay, for the initial design, several design suggestions was made, such as appropriate size, appropriate location to implement the prototype, and what type of component hardware we should use. And the final decision was made, and we come up with a portable RFID attendance system that can extract data from the RFID tags and integrate it with Microsoft Excel. And then a list of hardware component was listed as and was finalized, and all the components were acquired from a reliable supplier. Once we get the hardware, we started to integrate all the hardware with the microcontroller, which is the hub of our project. Uh, the hardware integration is as follows: integration of Arduino with an RFID module, integration of Arduino with RTC module. RTC stands for real-time clock. Uh, Integration of Arduino with micro SD card module, which can read and write to a micro SD. And then we have integration with servomotor. Servomotor is used to dispense sanitizer, and lastly, integration with ultrasonic. Ultrasonic is to detect the presence of hand, so that the motor will start to dispense sanitizer. Okay, moving on, we have software development. So each hardware integration was complemented with the presence of software development, like coding and data development, with alongside with Microsoft Excel to list the students' data and their credential. And hardware and software is the most crucial part of developing this prototype. Combining all the modules as one system and modifying the coding simultaneously. We done tests and troubleshooting repeatedly until we yield the desired the desired results. And finally, for the prototype, after all the modules were integrated, the system was set up in a form of permanent circuit board for commercialization. And lastly, final report and progress were written and recorded for submission. Okay, moving on to project design block diagram. So this is our a basic block diagram. So to visualize how our or what is our prototype. So we have Arduino as the microcontroller as the hub, and then we have RFID module, micro SD module, LCD display, RTC module, and servo motor. Okay, so this is our system architecture. The architecture of this prototype uh, is based on hardware software code design, on which can be classified into two distinct categories: hardware and software, which you can observe in the figure shown. Okay, the first part is we have the output, the input part, which consists of RFID module and ultrasonic sensors. And then we have the main hub, which have Arduino board, the microcontroller, and then the SD card module to read and write into micro SD, and we have RTC module, which used to record time and date when a card was swiped onto the RFID module. And then we have the output part, which is the LCD to display the student credential, including their names, their ID, and the time when the card was swiped. And the last part is the Microsoft Excel, which is used to integrate the data from that was collected from Arduino. So Okay, this is a hardware architecture of our prototype. So the system hardware is based on Arduino Uno R3 microcontroller. The entirety of the hardware can be divided into multiple parts, uh, which is LCD display, RFID module, uh, RTC module, micro SD card module, servo motor, and ultrasonic sensor. Okay, RFID is used to extract data from RFID tags. The workflow began with the microcontroller executing a command to the reader module, uh, along with an authorization key through the UART port to prevent unwanted access. If two possible instances occurred, one involving an authorized card and the other involving an unauthorized card, the reader will only send data to the microcontroller for the former, and the ID not registered will be shown for the latter. And then we got the LCD display. LCD display is an electronic display module, uh, which has which does have two registers, command and data, and it connects to the microcontroller via the SPI protocol. Uh, an authorized RFID card, when swiped, the LCD will display the student credential alongside the time and date, whereas an unauthorized card will result in ID not registered. And then we have micro SD card module. Micro SD act as a storage component which is coupled to the microcontroller through SPI protocol and powered by a 3.3-volt power source. The file system format is FAT32 and the function is implemented on the microcontroller. Moving on, we have RTC, which stands for real-time clock. It's a module that provides an I2C interface that is both standard and quick to implement. Its behavior makes it relatively easy to be coupled with a microcontroller, and is powered by an integrated coin cell battery that actually can last for years. So another function is it records time and date, real time. And then we have servomotor. It's an electronic device, rotary or linear actuators that rotate and push part of a machine. So this is used in our prototype to dispense a sanitizer from a bottle, from a sanitizer bottle. It only operates when it detects when ultrasonic sensor detects heat. In this case, hands. So every time it detects hands, it will dispense sanitizer. Okay, we have software architecture of our prototype. Making the hardware is just the first step to get the system to work properly. The embedded system is crucial for the hardware to work as intended. Even event-driven programming was utilized for this project. The language utilized is C programming, which is based on the microcontroller used, which is the Arduino Uno R3. And after the embedded system has been designed and constructed, application software will be created. There are two types of application software that should be evaluated. First is the swipe card procedure on the portable device come first, followed by downloading of swipe data onto the PC. The event-driven flow for the swiping card operation is shown in the figure. The system is initially inactive. The status changes to read mode once the RFID card is swiped onto the RFID reader. The reader will then detect the card and write the data to the microSD card, which is known as write mode. After the data has been stored, the status returns to idle. The data stored will be checked first, and then a new file will be produced in the updating section. The modified data will then be saved so that it may be transferred to a personal computer in readable format. After that, the system will be shut down. And lastly, we have Excel, Microsoft Excel. It is a software program that uses spreadsheet to organize numbers and data with formulas and functions. We use this Microsoft Excel to collect and save the data. When swiping the RFID tag or ID card at the module, the data will be recorded in the Microsoft Excel.
Today I want to talk about schematic design. By referring to this figure, the schematic had been constructed by using FreeXense software. There's all of the connection between the various parts of the RFID-based attendance system may be seen. To prevent any unintentional error that can disrupt the overall connection for the hardware element, the 5V and 3.3V VCC connection for electronic component should be kept separate. There is a button on the board designed specifically to reset the system that can be used to reset the coding on the Arduino Uno R3 board. And then the 3D prototype design is done by using Fusion 360 software. Each figure has been shown the top view, right side view, and the left side view of the prototype of RFID based attendance system, where at the top view is can see the LCD. As the left side of the prototype, you can see a hole for sanitized dispenser, and there is place where the ultrasonic sensor placed too. Okay, beside the hole there is a RFID sensor to detect the RFID card. And finally, at the right side of the prototype, there is a hole for the power supply, and all the circuit wiring are placed into the prototype body.
This is our RBUS system result, which is when you turn on, you will say RBUS system, scan your ID. Then, for the first scan, it will say your name and your number metric. It also have a timestamp, which is 48 right now, and the data insert. This is the second person, which is Kim, and they are in his name. The timestamp and the data inserted in the database. This is the second time you scan, which is it will also say your name and goodbye, be careful for the time out, and also your timestamp. This is the third time you scan, which is it will say done, see you tomorrow, to represent you already done for today class. The system not only will show here, but it will we also put in the Microsoft Excel for your enter time. And the second time you scan, it will show for the out time in the Microsoft Excel database. LCD will display ID not registered when your data is not in our database. As our system integrate with the Microsoft Excel, when we scan our RFID UID tag, it will automatically will say your date, name, identity, enter time, and out time. Then we will use Excel function to describe the class time, class end, late by, and status. For the late by column, it will show you how long have you been late, which is for 7 hours, and the status will show late. As for the late by, status show 0, it means the status will show not late. Then we differentiate between the status, both status, by the red and green color. This is our circuit system, which is our bus system, where we integrate together our servo motor and the ultrasonic sensor, which when we put our hand within 10 cm for the sensor, which is here, it will sense your hand, then the hand sensor will come out from this tube.
Safety is important when it comes to electrical appliances. There are some precautions that are needed to avoid such issues, such as never work on circuit while power is applied. Do not connect power to the circuit until the circuit is finished. Immediately disconnect the power if smells of anything burning, and other basic safety precautions. When it comes to culture and benefit, RFID based attendance system using Arduino saves a lot of time by swapping RFID tags or card compared to using the old method of calling names in classes. This system can also help the lecturers and students not to be in contact directly with each other. This can further reduce COVID-19 spread among people with the sanitization built in the project. This project can be used in all places such as school, universities, workplaces and offices, and it is very user friendly. As for this project, we have accomplished SDG 4, which is quality education. SDG 4 is built and updated education facilities that help students provide safety, non-violence, inclusive and exclusive learning environment for all. Digitalization is having a massive impact on labor market and type of talent need in education sector. Hence, this project help the future generation to utilize developments in technology. This attendance system can be used anywhere due to its easy accessibility. Certainly, everyone can save time and energy through this entire attendance tracking system.
Finally, our teammate can conclude the chapter present the final summary of the entire system and its requirements, including the recommendation for future works, other application of the sensor and the commercialization potential of the RFID-based attendance system. The RFID-based attendance system was proposed as a measure to combat the pandemic of COVID-19. It automates and prevents the process of manual attendance recording. The traditional method of signing names on the attendance form will be only cause close contact with other attendants, but it also induce students to skip class by having their friend to sign their names. With this, students can record their attendance without making physical contact, maintaining social distancing, and as a countermeasure to make sure students do not skip the classes. Okay, and then in development of the system, the Arduino Integrate development environment was used as its main platform. IDE is an open source and user-friendly tools to program their interface. RFID, RTC, and micro SD card module are essential to develop this system. A RFID reader is used to read RFID tag, and the Arduino will record the information and write it on data storage in SD card. This project is integrated to store data in Excel to make it more organized, where it helps the admin to have the data more comfortably whenever they need the data. In overall, the objectives are achieved for this project.